Okay, so let's walk through this question now. So let's find all of our terms. So I want to find my first term. Now notice that 2 is being raised, so I think my r is 2. So because it's the base of my exponent, so r is equal to 2. There is no number in front, so I know my first term is 1, but we can always test it out. A of 1 is equal to 2 to the power of 1 minus 1, which gives me 2 to the power of a 0, which is 1. So how many terms do I have? Again, 1 to 7. I have 7 terms. So again, what you can do is you can say upper limit minus lower, oops, erase that, upper limit minus lower limit, and then plus 1. So 7 minus 1 plus 1 tells you how many terms you have. So this one you don't necessarily need a calculator for. So S of 7 is 1 times 1 minus 2 to the power of 7, all over 1 minus 2. Notice that the 1's not going to make a difference right here. So 2 to the power of 7 is 128. So this will be 1 minus 128, all over negative 1. So negative 127 over negative 1. So S of 7 is a positive 127. Sometimes you will get negative numbers. Sometimes you will get positive numbers. So we have finite sequences for both geometric and arithmetic, but we can actually find the sum of infinite series when we are dealing with geometric only. So that's the last part that we're going to talk about today. So sum of infinite geometric series. All right, so our formula is going to look something like this. So S, sometimes you will see the infinity sign here. So S of infinity is equal to, so we're going to see our summation. So I is equal to our first term, so 1. And then we have infinity. Actually, that is supposed to be, oops, a 0. If we look at our book. So we are starting, really it's just the term that's going to start our sequence. So we'll have our formula, so a of 1 and then r to the power of I, so whatever that value is. So that's what we're going to see as the summation symbol. So our actual formula is going to look like this. We're going to take our first term. We're going to divide it by 1 minus r. Now for r, what we need to have is this. Your r must be, if we take the absolute value, must be less than 1. Okay? So a little side note here. We can't use if absolute value of r is greater than or equal to the number 1. Your series would have no sum. So you might be asking yourself, well, why is that the case? Okay, well, let's think about this logically. Say I start with the number 1 in my series, and my multiplier, let's just say, is 2. Make it very easy. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 32. So you're getting the point that these numbers keep getting larger and larger and larger. So if you sat here and you tried to add up all these numbers, your numbers would just be getting infinitely larger and larger and larger, right? So if I graphed this geometric sequence, but I used it as a function, what you're going to notice is your numbers get larger and larger and larger. Your output is getting closer and closer and closer to infinity, right? And you can't just add to infinity. We're not going to say our sum is infinite. Okay, so we're going to say that our R value has to be less than 1. So our actual R values are going to be less than 1. So what does that mean? So let's again take the number 1, right? And let's now make our R value a half. So half of 1 is a half. And then half of a half is a fourth. And then half of a fourth is an eighth, right? So let's think of this in terms of, say, a picture. If I wanted to draw a circle, and I'm going to fill in a whole circle. So that means all of this, draw a little bit bigger, all of this would be filled in, right? Boom. Filled in. There's my circle. So now I want to take a half. So I would be adding it, so that's that. And then I'm going to take a half. So let's pretend my circle was a lot better than that. And so I'm going to take a half of that. So that means half of my circle is filled in. So boom, boom, boom. So there's a half. And so right there. And then I'm going to take a fourth of that. So what that means is I'm going to take what's remaining and I'm going to fill in a fourth. Right? So fill it in red this time. Use a little different color. Right? So there's a fourth. And then I'm going to take a half of that. Right? So half of that would be this little piece right here. Okay? Now, if I keep just filling in half of half of half, I'm never actually going to fill the circle, but it's going to get closer and closer and closer to a number, right? Just like if we were to graph, right, geometric sequence, and it had a multiplier of a half, I would notice that my graph would get closer and closer and closer to my asymptote, but would never really get it. Okay, so what we consider this is the sum is diverging. Okay, it's getting closer and closer to our answer. Okay, so how would this look in an equation, right? So I would say, the sum, and we're just going to say n is equal, we're going to start with our first term and go to infinity. So my first term is 1, and I'm raising that, or raising 1/2 to the power of, n minus 1. So using our formula, so a of 1 all over 1 minus r. So my first term, 1, all over 1 minus a half. So this would be 1 over a half. Division is the same as multiplying by the reciprocal. So 1 times 2 over 1. So that means my sum is getting closer and closer to 2. That makes sense because I already have a whole, and then I keep adding parts of another whole together, and they're going to get closer and closer. Now, will all of our sums always get to an actual integer, right? No, that's not always going to be the case. Sometimes you will see problems get closer and closer to a decimal, and that's okay. Right? So, and we need to know a formula because I have never seen the infinity sign on this calculator, right? So if you can find the infinity sign, we can easily plug this equation in and press enter. Be my guest, but until we have that, we have to just use the formula and kind of go by hand. So if I say this, so 4 parentheses 0.6 to the power of n minus 1. Again, there's my r value, so 0.6 absolute value is less than 1, true statement. Making sure this is our a of 1 term. So 4 times 0.6, 1 minus 1. 4 times 0.6 to the power of 0. So 4 times 1 is 4. So what do we have? So the sum is 4 over 1 minus 0.6, which is 4 over 0.4. Technically, if you multiply the top and bottom by 10, right, this will be 40 over 4. So your sum actually gets closer to the number 10, right? Something that doesn't have a sum, so if you see something that looks like this, so n is equal to 1, infinity, so 3 times 2 to the power of n minus 1. Notice that my r right away, right, is equal to 2, absolute value less than 1, not the case. So we can just immediately say there is no sum.